Hello everyone, welcome to College Algebra. So in the first lecture, in the first chapter, we'll discuss prerequisites. So think of prerequisites as the base or the foundation. Alright, so these are introductory concepts. So we'll discuss these introductory concepts and then we'll enter into the real parts of algebra. So with that, let's start the first topic, numbers. So whenever we classify numbers, you have to remember that numbers are the basis of understanding of mathematics. So when we discuss numbers, so we talk about what we call the number theory. So we talk about the number theory. So numbers in general can be classified into two types. So the first type is real numbers and imaginary numbers. So real numbers are numbers that are finite. So real numbers are basically numbers that can be classified into further types. So one way of imagining real numbers is to think about the way we count numbers. So whenever we count numbers in a specific order. So real numbers are basically the numbers we use generally in real life. And imaginary numbers are special form of numbers. So these are special type of numbers. So real numbers again can be classified again into two types. So they can be classified into two types, rational numbers and irrational numbers. So we can classify them into rational and irrational numbers. And again, you can further divide rational numbers into two parts. One is fractions, the other is integers. Right? And imaginary numbers are single set of numbers. They use a base called I, which is defined as under root -1. So we'll discuss more about imaginary numbers in chapter 2 when we discuss equations and inequalities. There we have an entire topic on complex numbers or imaginary numbers. We'll discuss there a little more. Now in this chapter, let's focus on real numbers. So when we classify real numbers, think of it as numbers that are basically countable. Now, so when we classify real numbers, we said that there are two types. Number one is rational. The number two type is irrational. So what are rational numbers? Any number so that can be expressed in the form of p by q, comma q not equal to 0 is called as a rational number. So basically a rational number is any number that can be represented in the term of a fraction. So any number that can be represented as a fraction. Irrational numbers are numbers that cannot be expressed as a fraction. Or the form p by q where q is not equal to 0. So where you cannot explain them, so you cannot have, so that can be expressed here. So that's the only difference between a rational number and an irrational number. Now these rational numbers, again, let's focus on rational numbers. Can be further classified into two types. So one is fractions, the other is integers. So fractions are numbers where they have a p by q form, where q is not equal to 0. But integers are numbers with a p by q form, but where q is equal to 1. So which means that there is no value beneath the denominator. So whenever we write p by q, so the top is called as the numerator and the bottom part is called as the denominator. So if the denominator is always 1, those numbers are called integers. So if the denominator is not 1 but any other value, then we call that fraction. So you think of fractions as a subset of think of integers as a subset of fractions. Now you can split again integers into two types. So we have negative integers and non-negative integers. So we have negative integers and non-negative integers. Negative integers are numbers, for example, like -2, -1 or -5. So these are numbers that can be considered as negative integers. Non-negative are 0, 1, 2, 3 and so on. Anything that's greater than 0. Right. So think of these as subsets of numbers inside the original set again. Now in the non-negative numbers we can classify two subsets again. One subset is the natural numbers, the other subset is the whole numbers. Natural numbers start from 1 and they go on infinitely until n. Whole numbers start from 0 but they end up with the same value. So they end up going on to the same place again. So all negative integers are basically numbers, for example, from -1, -2 and so on until -n. So these are negative integers. Understand that n here does not represent the actual value, it can be infinite values. So here also the value can be negative infinity. So which means the values can go on until the end. Now, so we discussed the types of integers. Now let's focus on rational numbers where we talked about fractions. So fractions are basically numbers where you have a p by q form. There are two types of them. So any fraction can be represented as either 1 as a terminating decimal or number 2 as a repeating decimal. So for example, if you take a calculator and type 15 by 8, you end up with a value of 1.875, which means that after 5 there is no value left, so it means it stops at 5. So there is no value after 5. So this value stops at 5. But if the same value, if you take for example say 4 by 11, you end up with a value that looks somewhat like this, 0.36, 36, 36 and so on, which means that there is no stopping point to this. So what we do then is we take the numbers that are repeating and we write a bar on them. So this symbol represents that it's a repeating decimal. So it's a repeating decimal. So this is how we can classify the numbers based on the properties that they have. Now, so let me write down some numbers and see if you can classify them as a rational number or an irrational number. So 7, 0 and -8. So I'll do the first one and you can do the rest of them. Now, we told that every number should be written as a p by q form. So can 7 be written as a p by q form? Yes. So you can write 7 as 7 by 1. Or you can also write 7 as 14 by 2. It doesn't matter how you write it. If you are able to write it in a p by q form, then we can simply say that the value satisfies the case that it should be a rational number. So it's a rational. Now, so pause the video right here and try if 0 and minus 8 satisfy the definition of a rational number. Next. So I have another 3 numbers. So minus 5 by 7, 15 by 5, and 13 by 25. So let me do the first one. So if you calculate using a calculator minus 5 by 7, you get a value which goes like somewhat like this: minus 0.714285, 714285, and so on. So which means that this is the number that's repeating. So what we do here is 0.714285, and we put a bar on it. Now this represents that this is a number that continuously repeats itself. So this becomes a repeating decimal. So this is a repeating decimal. So in the same way, try number 2 and number 3. So see whether it's a terminating decimal or a repeating decimal. So pause the video right here and try number 2 and number 3 to check if it's a terminating decimal or a repeating decimal. So the first one is a repeating decimal. So next, let's talk about irrational numbers. So what is an irrational number? So irrational number is basically not a rational number. So one simple way of saying this is it's not a rational number, which means that this is a number that cannot be written as a p by q form, where q is not equal to 0. So we cannot write it as a p by q structure. So which means that this is a irrational number. So let's take an example. For example, let's say I have a number root 25 and I have a number root 11. So let's find out if you can write each of these numbers as a rational or an irrational number. If you take root 25, you get, if you know that root 25, you end up with a number 5. So square root of 25 is 5. But can you find the square root of 11? So there is a question mark. The reason we cannot find square root of 11 is because 25 is a perfect square, which means that you can write 25 as 5 square. But 11 is not, which means you cannot write 11 as something square. So we do not know that number. So that's the reason why, because there is no value, what we end up doing is this is a number that does not have any way of writing it as a rational number. So what we now do is we'll call this an irrational number. So we cannot call this an irrational number. So now let's try and see if you can understand let's see if we can understand the concept. So let me write down some numbers. So you have 33 by 9, you have 17 by 34, 0.3033, 0333, 0333. So and goes on. So we talked about the first number root 25. So let's look at 33 by 9. So can we write it as a fraction? So 33 by 9 in itself is a fraction. So it's already a fraction, right? It's already written in the p by q form. So which means that this here is a rational number. So this here is a rational number. But when you look at 17 by 24, 34 again, so 17 by 34, it's already a fraction, and you can further simplify this. So you can write 17 1, 17 2s, and you can write it as 1 by 2, which is also a fraction again. So which means that this here is also a rational number. Now let's look at the last number. So the last number here is not a terminating decimal. So it's not a terminating decimal for first up. But the problem is there is no repetition pattern as well. Notice the repetition pattern. Remember that if it's a repeating pattern, then we can still write it as a fraction, right? But it's not repeating, so we cannot write it as a fraction. So what we do now here, so notice the repetition. So it's 3 0, so you have 0 double 3, 0 triple 3, 0 quadruple 3, which means that it's not repeating the same way as we expected it. So this here is an irrational number. Right? So an irrational number can be classified as a non-repetitive, non-terminating decimal. So for this value we can write that an irrational number is a non-repetitive and non-terminating decimal. So this is the examples of rational and irrational numbers. So let me write down some more. So pause the video right here and try to see if each of them, so try to classify them as a rational number or an irrational number. So pause the video right here and try to solve them. So let's talk about real numbers. So real numbers in general are denoted by the set R. So R is the symbol that we denote for real numbers. So real numbers is the combination of rational and irrational numbers. So it's a combination of rational and irrational numbers. So notice that these are two different sets, and both the sets combined conform to real numbers. So for example, rational numbers are given a symbol q and irrational numbers are given a q dash. So real numbers are basically q union q dash. So union represents combination, right? So this is a symbol that represents combination. Now let's talk about real numbers in general. How do we visualize real numbers? Real numbers in general are visualized on a number line. So they are generally visualized on a number line where we write the value 0 in the middle, and anything to the right represents the positive values. So anything to the right represents the positive values, anything to the left represents the negative values. So for example, towards the right you end up getting 1, 2, 3, 4 and so on, and to the left you get -1, -2, -3, -4 and so on. Doesn't mean that these are all integers. Notice that between -3 and 4 there are a bunch of values as well. These are fractions, all the values included. Notice that in real numbers we consider every single value, right, that is rational or irrational. It doesn't matter what the type of number is. Next, to classify anything to be a particular type of a number, what we generally do is we classify them based on that number line. For example, let's take a bunch of numbers, say -10 by 3, root 5 minus root 289 minus 6 pi and 0.615384615384 and so on. Now in these numbers, notice that there is a specific understanding of how the number is made. So you have minus 10 by 3. So the first thing we generally do is draw a number line, draw a simple number line. So let's say we have 0 in the center, and to the right we have 1, 2, 3 and all the positive numbers, and minus 1, minus 2, minus 3 and all the negative numbers. Where would you place negative 10 by 3? Negative 10 by 3, the first thing we already know that this is a negative number, and if you look at the value, it's a fraction. So it's a fraction. You can simply say that this is a rational number. Say for example, minus 10 by 3, if you write the actual value, you'd get about 3.33 and so on. So for that, you end up with somewhere here. So this is the number is to the left of 0. When you take root 5, so root 5 is a number that is positive, first things first. Next, it's also irrational. Notice that 5 is not a perfect square, so it's an irrational number. So but if you take the actual value of root 5, it's going to be positive for sure. So which means that it's on to the right of 0. Now this way, try doing other numbers as well. So for my tip, 289 here is a perfect square, 6 pi is a rational number, and this here is a repeating decimal. Notice that 615,384, 615,384 is a repeating decimal. Now, so this is the set of numbers in general. Now let's take the whole set in general and let's see how we can simplify all of these sets. The smallest of all of them is the set of natural numbers, and outside the set of natural numbers we get whole numbers, and outside whole numbers we get integers, and outside integers we end up with rational numbers. So let's take for the first set. So the first set here is 1, 2, 3 and so on. So this is the set of natural numbers. Next, to this set, if you add 0, we get whole numbers. Notice that this can encapsulate the entire set. Now to all of these numbers, if we add the negative numbers, minus 3, minus 2, minus 1 and so on, we get integers. So we get integers, and to all of the integer values, if you add m by n, or where n is not equal to 0, or p by q where q is not equal to 0, we get the rational numbers. To this numbers, anything outside this set becomes q dash. So q dash is, for example, pi, root 2, etc. All of these values are irrational numbers. So this is the entire set of, so when we consider this entire page represents the set of real numbers. So this entire page represents R, the set of real numbers. Now, so I hope you understand. If you have any doubts, just review it again so that you understand the concept. So now, let's go to the next topic, order of operations. So I hope you already know some simple arithmetic for this. Now, whenever we talk about an exponential value, so when we have, there are two types of things that I want you to remember. When you have a single number and you are adding up n times, what do you get? So you're adding n times and a single value, so it becomes n times a. In the same way, when multiply a value n times, you end up with a value of a power n. So this is an example of the terms of operations, so the order of operations. This here is the additive factor and this here is the multiplicative or the exponential notation. An exponential notation, you have a power n. A here represents the base, n here represents the exponent. So a here represents the base and n here represents the exponent. Now, so with that in mind, let's talk about the order of operations. For example, let's say if you have a complex operation, say 24 plus 6 times 2 by 3 minus 4 square. Now the dilemma that comes in here is which operation to do first. Is it the addition, is it multiplication, or is it subtraction, or is it exponential values? So to make this easier, what we generally do is we use a set of simple acronyms that represents the entire process. So that is represented as P, E, M, D, A, S. So let me write it. PEMDAS. What we do here, so the first preference is always given to parenthesis. So anything in brackets, so parenthesis for example is brackets, or brackets is general brackets or parenthesis in general. Next comes exponential values, so exponents. So always give all priority to exponents. Then after that you can give priority to either multiplication or division. So the next priority can be from either multiplication or division. Next, after that you can do addition or subtraction. Always addition or subtraction is always to be done at the last part. Now in this given numbers, let's try and do them for first step. So the first step is P. Is there any parenthesis here? So no. So we don't need to worry about it. Next, E. So there is an exponential value. So now 24 plus 6 times 2 by 3 minus, there is 4 square. So 4 square is 16. Now we have converted the exponent into a general value. Next, exponents, so there is no exponents left. So we are done with this step. Next is either multiplication or division. So either multiplication or division. You can choose any one of them first. So I am going to choose division first. So you have 6 times 2 by 3. So you can consider 3 times 3 2's. So it becomes 2 times 2 minus 16. So the multiplication or division is done. In the next step, we have done division now in the first step. Next, let's do multiplication. Multiplication, we are combining 2 times 2. So it becomes 24 plus 4 minus 16. Now, in the next step, we have to do either addition or subtraction. So let me do addition first. So you have 24 plus 4. So use the two values and add them. So you get 28 minus 16. So 28 minus 16 is done. Now finally there is nothing left. So only subtraction. So subtraction is 28 minus 16 gives you a value of 12. So the value for 24 plus 6 times 2 by 3 minus 4 square is going to be 12. So this is the value for the problem. So this is the order of operations. So let me do another example. So I have 5 square minus 4 divided by 7 minus under root 11 minus 2. So the first step is P. So there is no P left here. Next you have exponents. So understand that exponent means that it uses everything. So even a square root comes under exponential values. So but there is no other choice. Let's use the exponent first. So 5 square is 25 minus 4 by 7 minus under root 11 minus 2. Now when we consider the entire structure here, so the next thing we have to do is think about parenthesis. I'm sorry, I am really sorry for that. Let's start over again. So here the parenthesis includes the number inside the square root. So let's use that parenthesis first. So which means that it becomes 5 square minus 4 by 7 minus under root 11 minus 2 becomes 9. So that's the first step. So the first step is done. Next step is the exponents. So the exponent step, we use 5 square minus 4. So the exponent step, 5 square is going to be 25 minus 4 by 7 minus root 9 can be written as 3. So now next 25 minus 4 can be written as 21 by 7. So that there is no addition, so there is no multiplication or division, and there is nothing of this sort. So as of now there is nothing of this sort. So let us do the first step, which is the addition or subtraction. There is no addition, so but there is subtraction. So there is only subtraction. So let's do the subtraction. So 25 minus 4 gives you 21 by 7 minus 3. Now 21 by 7, this can be considered to be the main part. So 7 ones, 7 threes. So it becomes 3 minus 3, which gives you a value 0. So the value for 5 square minus 4 by 7 minus under root 11 minus 2 becomes 0. So use the sequence of operations properly and you will end up having a proper value. So try the following problems. You have 3 times 2 square, so this is times, minus 4 times 6 plus 2, or parenthesis 6 plus 2, this is the first problem. And the second one, you have 14 minus 3 times 2 divided by 2 times 5 minus 3 square. And in the third one, you have 7 times 5 times 3 minus 2 . So try these 3 problems and try to use the order of operations method, and slowly you will end up getting your answer. So pause the video right here and try to solve these problems.